first session of the day. If you want, if you are ready.
Yes, I'm ready. I can start.
First paper belong to dear Zehra Sude Sarı.
Yep. Let me share my screen.
Please.
Is it visible for everyone?
Not yet. Yes. It's a
It's
bit.
can you
Yes.
please yeah, okay.
You have 10 minutes, please.
Yes, okay. Dear listeners and moderator, my name is Suda Sarı. I work as R&D specialist at Mocha United. Today, I will be presenting our paper titled Development of Machine Learning-Based Revenue Forecasting Models for Electronic Payment and Money Institutions. In this presentation, I will briefly explain my study through 7 main sections. First, I will introduce the topic and its importance. Then I will present the aim of the study and summarize the related literature. After that, I will describe the dataset and explain the methodology. I will then talk about prediction models and develop the prediction models I developed and shared results. Finally, I will conclude the presentation with key findings. Electronic money is a digital payment tool used like physical cash. And electronic money institutions offer services like money transfers, post solutions, digital wallets, and prepaid cards. They earn revenue through commissions, transaction fees, and service charges. Revenue forecasting is vital for cost management and strategic planning, and accurate forecasts support financial sustainability and competitive advantage. And this study aims to develop revenue forecasting models to enable accurate financial planning. To this end, forecasting models have been developed using CatBoost and SVM. Furthermore, the study aimed to analyze the impact of feature selection and loopback integration, which allows forecasting future values using a certain number of historical data as input on forecasting performance. The literature shows that deep learning, hybrid time series models, and optimization-based approaches can generally outperform traditional methods in financial forecasting. LSTM-based models, ARIMA-NN hybrids, and intelligence decision support systems are especially effective in capturing complex market patterns and improving decision-making. Due to time constraints, only 3 representative studies have been included in the table below. However, approximately 10 academic publications were reviewed in total, and detailed summaries of the remaining works can be found in our full text. The dataset is in a weekly format and contains 193 rows, and it covers the period from the May 1st, 2021, December 31st, 2024. The table lists all attributes included in the datasets. And the first column contains time-related features such as year, month, week, quarter, as well as financial variables like transaction volume, commission rate, and total revenue. And the second column includes weekly Euro, USD, and BIST values such as opening, closing, minimum, and maximum prices. These attributes allow the model to accurately capture both financial movements and revenue-related patterns. Let's look at methods. First one is categorical boosting, an open source gradient boosting algorithm that efficiently handles categorical, numerical, and missing data. It offers fast training, GPU support, and visualization tools. Key parameters include tree depth, learning rate, and number of trees. Feature important ranking are preferred for iteratively improving variables. Second one is super-vector machine, a supervised learning algorithm used for classification and regression, especially effective on small, high-dimensional, and non-linear datasets. Based on statistical learning theory, it maximizes model generalization by minimizing classification error. Key parameters include the cost and kernel function. Weekly revenue forecast model have been developed for the week of 9th to 15th of September 2025 2024, and 2nd to 8th of December 2024. Monthly revenue forecast models have been developed for the months of September and December 2024. CATBOS and SVM have been developed, have been used in the model development, and the impact of LV on look back, by the way, on forecast performance has been analyzed, and the MRMR feature selection algorithm has been applied. You can see real and forecast values of the models developed for September are presented in the graphs. This figure shows the forecast and real values of the SVM model, and figure 2 shows the forecast and real values SVM plus feature selection model. And we can see the performance of the feature selection algorithm for SVM in the figure 2. And the figure 3 shows the forecast and real values of SVM and lookback, SVM plus lookback model. And the figure 4 shows the forecast and real values of SVM, feature selection and lookback model. This is the forecast and real values for the SVM and lookback, and forecast and real values for SVM lookback model. Okay, let's see the old performance. And the table shows the Maya and MAPE values of the developed models. The first column is for weekly models, and the second column is for monthly models. Okay, for the result and discussion part, SVM feature selection and lookback model with a MAPE of 0.17%, and the CatBoost model with a MAPE of 0.14%, and they achieved similar results in the weekly models. SVM plus feature selection plus lookback model with a MAPE value of 6.5% provided the highest performance, forecast performance in a monthly models, while CatBoost showed a lower forecasting performance than SVM. Applying both feature selection and lookback integrations to SVM, they improved models performance. CatBoost models showed high forecast performance in a weekly forecast without feature selection and lookback integration. However, accuracy declined significantly in monthly forecast when these were applied, like due to CatBoost strong built-in feature handling. And in general assessment, the SVM plus feature selection and lookback models developed for September stand out superior models in both weekly and monthly forecasts. CatBoost has been found to be strong in weekly forecasts, however, failed to achieve the expected success when lookback and feature selection have been added. It has been observed that the performing feature selection with MRMR improved the forecasting performance for SVM while increasing the MAPE value for CatBoost. Sorry, I missed the December graphs, and let me pass quickly. Figure 9, 10, 11, and 12 shows the December graphs. For the forecast model for December, the CatBoost feature selection and lookback model has provided the highest predictive accuracy with the lowest MAPE value of the 0.03% in models developed for weekly forecast. For monthly forecast, the CatBoost and lookback model had the lowest error rate. Using lookback integration improved the performance for models developed for both weekly and monthly forecast. While feature selection has been beneficial for weekly forecast, it negatively impacted performance in monthly forecast, particularly in SVM model. In conclusion, nowadays the transaction volume of technology-based electronic payment and money institution is constantly increasing. Consequently, the service quality provided by these institutions is expected to be constantly good. Revenue forecasting is important for business aiming to conduct effective financial planning and resource optimization. In this study, revenue forecasting models have been developed using SVM and CatBoost. Furthermore, The effects of feature selection and loopback interrogation on model performance have been comprehensively examined. While SVM performed better in the models developed for as September, CatBull's model showed high success in December. The loopback and feature selection integrations yielded comparable results. This is my presentation. Thank you for listening. I can both answer questions in English or Turkçe.
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no questions. Thank you again. I wish you success.
Thank you. But
Next.
I have a question. I have to go to work, so I have to leave the meeting. Is it okay for you?
Okay,
Thank you so much. Have a good day for everyone. Thank you.
thank you.
Thank you.
Next paper belong to dear Ulaş Genç.
Okay, I will start the...
Are you ready to present?
Yes, I am.
You can share your screen.
One
You have 10
second.
minutes, please.
Okay. Sorry, I have a quick problem with the screen sharing. I'm just coming in a second.
Okay.
Okay. You can see the screen, right?
Yes.
Okay, I'm starting. My name is Ulaş Genç. I will present you precedent-aware legal reasoning system for Turkish jurisdiction with REC-supported LLMs. Firstly, I want to start with highlighting why we need AI assistance in law. Lawyers or legal professionals spend hours and sometimes days to find the correct precedents to support their ideas, their subject topics. And AI can accelerate that research by many times. Also, AI can... Also,
Bizim şeye de
oh, sorry. Or also, AI can summarize long texts of precedent and case decisions and give a explainable, reliable content. This is a GPT-5 approach. When we ask a question to GPT-5, as in the left page, it gives an answer in seconds or minutes. So it's really time-saving and efficient. Also, when we ask the decision they can support, can it support its ideas, it will give a Court of Cassation's official precedent case, past case, to support its idea. That's perfect, but in reality, it's not correct. The answer it gives is not correct, and after that, it fabricates a new, non-existent case to support its idea. And in literature, we call it hallucination. So first problem is a trust problem. We cannot trust LLMs because they produce fluent but unverifiable data for legal professions. It creates a trust gap in legal use. The second problem is the Turkish context. There is not enough public data on Turkish datasets. So therefore, models are not fully adapted to Turkish legal language either. Our contributions, we created a large-scale comprehensive Turkish legal dataset and also fine-tuned two models, two domain-specific models, one for embedding and retrieval, the other one for generation. We also suggest reproducible foundation framework for Turkish legal AI. How we created the retrieval dataset. There was no public dataset and we created by ourselves. So in the right, on the table, in the right side of the page, you can see the structure of our dataset. We scraped 55,000 raw decisions from Court of Cassation's official online archive on intellectual, industrial property, and trademark law. Some of them were unuseful and not leading. We eliminated them by care, by reducing them 30,000 high-quality processed decisions. We derived two different data sets from our base data set. They are for fine-tune purposes. First one has 50,000 synthetic legal question answer pairs from each precedent itself and be used for the generation tasks. We trained QN3 base to be our own LexiTurk 14 billion generation reasoning model with this data set. Also, we created LexiTurk embedding model with triplet loss data formats we created. With these two, we aim to enable citation-aware, explainable, and legally grounded reasoning. Our system diagram. Here, we have two main parts. One is retrieval, the other one is reasoning. We also have three configurations for retrieval tasks. If BM25 is selected with the BM25 algorithm, we check the similar lexical similarity between the question and the cases we have and retrieve three most relevant cases lexically. When vector similarity is selected, it checks the semantic similarity between the question and the precedents cases we have, past cases we have. Firstly, our embedding model translated past cases into vectors in our vector database and does the same to the question as well. And we check the cosine similarity between our question vector and the precedent vectors to find the most related three precedents past cases to our question for their help and support. And we pass these cases with the question to the large language model for reason over them and find the solutions of the question in the precedents. After that, with the right prompting, large language model gives the answer and reference back to the user. That's our demo application and suggestion. The user asks a question on the top, as you can see. After that, our system gives an answer. And after the answer, as you can see, there's a reasoning. It explains why it got to that decision, that answer, by reasoning it over every document, every single document, document 1, document 2. And below it, you can see the citations. And below it, there are the original case sources. When you click on them, it will take you to the Court of Cassation's official website and it will show the original text of the case. And it will make the verification possible. Now it's time for the evaluation. There were no public Turkish legal benchmark, so we created our own evaluation method. We used HDB scan clustering algorithm and made 1,000 clusters. After that, manually, we checked and found the best 100 clustered clusters and made a question out of each of them, as you can see in the right part. There are 4 decisions and 1 question which will cover all of them. And as the evaluation, when we asked the question, we checked how many of the decisions it will retrieve. And that was our evaluation metric. As you can see here, GNI embedding, open source model GNI embedding shows the highest scores in the hybrid settings. So we can tell hybrid outperforms the other settings as dense and sparse. In contrast, our own made model LexiTurk also achieved high improvement over its base model Berkturk, almost 3 times better than that. So it shows the need for domain adaptation in this point. Also, there is a generation evaluation after our retrieval evaluation, the second part of our work. We created 100 synthetic legal questions generated from real precedents using Gemini 2.5 Pro. Each question is manually checked by legal professionals and linked to its true precedent for grounding. As evaluation setup, we use 2 configurations, closed book and reg enabled with retrieval, and compared them across GPT-5, GPT-OSS 20 billion, QN3 14 billion, and our own made LexiTurk 14 billion model. For evaluation method protocol, we used LLM as a judge protocol, which is said to be similar to real professionals in 80%. in the literature. We scored it out of 1 to 5 Likert scale, and on metrics such as correctness, completeness, faithfulness. Correctness means the accuracy of our answer. Completeness is how much of the question the answer covers. And faithfulness is how faithful is the answer to the source document, such as precedents, cases, past cases. In the generation test results, we can again see our Lexi-Turk model, domain-adapted Lexi-Turk model, just outperformed its base model and the other outsourced models in the same size. And also we can say here, even the largest models such as GPT-5 can gain improvement over RAC methodology, our RAC methodology, in both correctness and completeness. As a conclusion, we can say RAC significantly boosts correctness, completeness, and faithfulness in Turkish legal question answering. Lexi-Turk models outperform their base models, proving the impact of domain adaptation. And precedent-grounded reasoning enhances transparency, reduces hallucinations, and suggests legal reliability. Thank you for listening. If there are any questions, I can take.
Thanks for your presentation. Department, do you have any question about the study? Okay, no question. Thank you again. I wish you success.
Thank you.
Next paper belong to dear Betül Karaoğlan. Dear Betül Karaoğlan, are you online?
I think she's not here.
Okay. Dear Ayşe Elif Canbilen.
Yeah, I'm here.
Okay. If you are ready, you can start your presentation while sharing your screen.
Okay. You can see it now, right?
Okay. You have 10 minutes, please.
Okay. It's Ayşe Canbilen from Konya Technical University. Today I will be presenting our work with my master student Muzamil Suyu. And the work is titled Deep Learning-Based Dynamic UAV Positioning System Design. I'll make a brief introduction, then I will introduce our system model and the deep learning-based approach. I will be presenting our simulation results and then conclude the work. Okay, here. Actually, it's not a secret that the terrestrial networks will be inadequate at some point, considering the requirements of 5G beyond technologies, such as ubiquitous coverage and data rate demands. To overcome these problems, we need innovative technologies that can support terrestrial infrastructures or ensure network redundancy, such as non-terrestrial networks. NTN, non-terrestrial network, mainly includes satellites, HAPS, and UAVs located at specific altitudes in space, and each inherently has various advantages. Our focus in the study is UAVs, which positioned at low altitudes, typically below 10 kilometers. And they can be useful in disaster areas, IoT networks, emergencies, unserved areas, and many others. And UAVs are also beneficial in positioning scenarios thanks to their flexible mobility and wide field of view, especially in regions with insufficient terrestrial infrastructure. UAVs stand out as mobile positioning platforms. Here, positioning is the process of determining the location of an object, user, or device in a physical environment. Indeed, there are some studies in the literature aimed at solving the positioning problem. However, they have limitations, like they either require centralized control, which cannot scale to large networks, or cannot simultaneously achieve energy efficiency, rapid response, and fairness altogether. And additionally, some of them ignore real-time movement of users or dynamism of environments, while some others focus solely on maximizing coverage. And on the other hand, the traditional UAV deployment process typically involves statically assigning a location or a predefined flight route. And this limits the potential for dynamic adjustments in situations involving mobile users on unexpected interruptions. In particular, static allocation leads to inefficient coverage, energy waste, and uneven coverage and/or service delivery. Therefore, dynamic adjustments must be made during the UAV deployment, and to meet these requirements, we propose a deep reinforcement learning-based dynamic UAV positioning system in this study. And deep learning is actually a type of machine learning that learns from data using artificial neural networks and mainly divided into supervised, unsupervised, and reinforcement learning categories. In supervised learning, as you may know, the model is trained using labeled data, and in contrast, unsupervised learning learns patterns from a data without labeled outputs. And reinforcement learning has some kind of different process in which it trains an agent performed actions in environment to maximize the total reward. And deep reinforcement learning is a powerful extension of traditional reinforcement learning that integrates deep neural networks to process high-dimensional and continuous state or action spaces. And it uses DNNs to approximate the policy function, value function, or both based on the observations and rewards. Deep reinforcement learning algorithms can be broadly classified as follows in this slide. And in the model-based approach, the agent first tries to understand the rules by creating a mental map of how everything works. On the other hand, the model-free approach does not bother with all this planning. Instead, it learns by trying things out and remembering those that yield good results. And both has many methods under them. And among these methods, we choose DQN, DDQN, and dueling DQN methods to apply our dynamic UAV positioning problem. And the basic idea for DQN is that the neural network predicts Q values for state action pairs, while DDQN reduces overestimate bias in Q value updates. And the dueling DQN breaks down the Q value into state value and action benefits. All has some advantages and disadvantages compared to each other. Like the DQN is simple and effective for many tasks, while the DQN is more stable and provides improved performance in many cases. And while the dueling DQN is stated as better, providing better state value estimation and faster convergence in the literature. So we would like to apply all these algorithms to our optimization problem. And in our scenario, there are, as you can see, 100 ground users dynamically entering and exiting an area of 4 kilometers square. The UAV in the system operates as an intelligent agent trained using deep reinforcement learning to autonomously reposition itself for optimal performance. And specifically, the UAV learns optimal positioning strategies to maximize coverage, minimize power consumption, ensure fairness between users, and provide rapid response to disaster areas as they arise. Here we introduce our channel and coverage model, fairness index, and power consumption calculations with emergency response flags. And as we use the deep reinforcement learning, we have state space, action space, and reward functions, as you may see here. And the state space is composed of 3D position of the UAV and the user positions, coverage, emergency response, and energy respectively. And the UAV has 7 possible actions denoted as A0 to A6 which presents the up, down, forward, backward, left, right, and diagonal movements. And the reward function is used to evaluate the UAV's performance in specific locations, and represented here by RT, and coverage, energy consumption, fairness index, and emergency response based reward function is provided here. And the optimization objective of the reinforcement learning here is to train the UAV to learn the optimal action value function Q given here, representing the maximum expected cumulative reward that can be achieved by acting in case state S and following the optimal policy thereafter. And we have some constraints here given on the right side of the slide. The total energy consumed during the mission must not exceed maximum energy budget of the UAV. The cover provided to each user must remain above a minimum threshold. The overall fairness index must be greater than or equal to a specified value. And emergency response metric must be no less than the required minimum. So we have here the simulation settings given here. I'm not gonna go the details here, and we'll come to the simulation results. So we see here the comparison of the three methods, as we mentioned before, like DQN, DDQN, and dual-link DQN to solve the optimization problem of the dynamic UAV positioning system. And as we see that the increasing episode improves all the system's performance for each methods. However, the best results are obtained by the dual-link DQN. And if we come to the fairness comparison, we see that again the dual-link DQN provides the best results with the highest rate for fairness. However, improving episodes, increasing the number of episodes provide improved performance for the other two methods too. And for the power consumption, we see that the methods provide very close performances at some point. However, increasing episode provides less power consumption for the system uses using the dual-link DQN methods. And if we come to the training reward, we see that the dual-link DQN reaches a fixed point, fixed value faster than the others, and the value closest to zero provides the best results between them. So we can still say that the dual-link DQN provides the best result between all these methods. And here we see the emergency response for all the methods, and still the increasing episodes provides a higher emergency response. Here we mean by emergency response is that, let's say we have hundreds emergency cases for each episode, and the percentage here gives the number of responses that the system provides for each cases. So we see the improvement for all cases here. And as a conclusion, we can say that our system improved the wireless coverage, energy efficiency optimization, and equitable service distribution altogether. And all algorithms enabled the UAV to provide effective service in dynamic environments. And clearly, the dual-link DQN performed best in terms of coverage, stability, and fairness. And we assume that this work lays the foundation for future smart UAV-based wireless network systems. We see our references here. And this is all I would like to present to you. Thank you for listening. If you have any questions, I'll be happy to answer.
Okay, thank you for your presentation. Dear participant, do you have any question about the study?
Thank you.
Okay, thank you again. I wish you success. Next paper belong to dear Kezban Alpan.
Hello, good morning.
Hello, are you to present?
Yes, can you let me know when my screen is visible, please?
Okay. Okay, you can start your presentation. You have 10 minutes, please.
Okay, thank you. So good morning. My name is Kezban Alpan and I'm a PhD student at Middlesex University, London. And today I will talk about advances in unit and image processing, which leads a path to early cancer diagnosis. Cancer remains the second leading cause of death worldwide following cardiovascular diseases. According to the World Health Organization, there were 20 million cancer cases in 2023. And by 2050, this burden is expected to rise dramatically to 35 million cases, placing even greater pressure on health systems. Understanding cancer staging is crucial. In stage 1, the tumor is small and confined to its original organ, making treatment highly effective. But in stage 4, the most advanced stage, cancer metastasizes to other organs, and at this point, cancer cells become more resistant and standard treatments such as chemotherapy may be less effective. For this reason, early diagnosis is absolutely vital, and detecting cancer before it spreads gives patients the best chance for successful treatment, longer survival, and a significantly improved quality of life. Medical imaging plays a vital role in the early detection, diagnosis, and treatment planning of cancer. A wide range of imaging modalities such as mammography, X-ray, ultrasound, CT, PET, and MRI helps clinicians visualize internal structures and identify abnormal growths as shown in Figure 1. These tools are essential for screening and monitoring disease progression. However, despite their widespread use and technological advancement, histopathology remains the gold standard for confirming a cancer diagnosis. Image enhancements plays a key role in improving the quality of digital medical images by sharpening important features and increasing clarity. These techniques make subsequent analysis far more accurate. In clinical settings, this is particularly important because low quality or low contrast images can easily lead to misdiagnosis. Methods such as construct adjustments significantly increase the diagnostic value of an image and support earlier, more reliable clinical assessment. Alongside, the unit model has become one of the most widely used deep learning architectures for biomedical image segmentation, and its encoder-decoder structure effectively extracts features and provides precise localization, while skip connections help combine deep semantic information with fine, high-resolution details. This design makes the unit both powerful and effective, enabling highly accurate cancer segmentation, even when only limited medical data is available. This study examines how image processing techniques and the unit segmentation architecture each contribute to medical image analysis for cancer diagnosis. It evaluates the combined effect of these approaches in enhancing diagnostic precision and supporting more efficient treatment planning. As a first step of my review study, I want to mention image processing studies for cancer detection. And as I mentioned before, image processing plays a crucial role in improving diagnostic accuracy across different medical imaging modalities. And studies repeatedly show that effective pre-processing is not just optional, it directly determines the reliability of downstream segmentation, detection, and classification. For example, Choudhury and Singh compared FFT, auto enhancement, and Gabor filtering on CT scans for early lung cancer detection. And Gabor filtering produced the sharpest tumor visibility, and watershed segmentation outperformed thresholding, providing that pairing advanced filters with intelligent segmentation leads to more dependable results. Another example, Avinash and colleagues evaluated enhancement techniques on lung X-ray images using PSNR as a quality index, and the alpha 3 filter achieved the highest PSNR, demonstrating that even small improvements in noise reduction can substantially upgrade diagnostic clarity. In ovarian ultrasound imaging, Kamala and Shivaram showed that the Dobensky's wavelet filter achieve excellent PSNR and SNR and very low MSE, highlighting wavelets as powerful tools for noise-heavy ultrasound data. Together, all these studies show that well-designed pre-processing enhances construct and reduces noise, preserves structural information, and ultimately supports earlier and more accurate cancer diagnosis. When we evaluate applied unit studies for cancer detection, as you know, UNET has proven to be one of the most adaptable and most effective architectures for cancer image segmentation. And across many studies and imaging modalities, it consistently delivers strong performance. Some examples: early work by Hu and colleagues use a 2D unit, 2.5D unit on MRI for nasopharyngeal cancer, achieving a DICE score of 0.6 and highlighting that 2D unit remains more efficient than 3D variants. And in breast cancer, Robin et al. Used unit on histopathology images and reached an accuracy of 94.2%. And for colorectal adenocarcinoma, Wang's PPC unit achieved a DICE score of 0.8. UNET also performs very well in ovarian cancer research. Zhu et al. Combined ResNet with UNET for ultrasound images and achieved 89% accuracy. On the other hand, Saha and colleagues introduced MUNET, which merged MobileNet version 2 with UNET and obtained 98% for accuracy for ovarian follicle segmentation. Across these studies, one message is clear: UNET and its many variants consistently provide high-quality segmentation and with limited data and diverse imaging techniques. Their strength in capturing structural detail makes them a foundation of modern AI-driven oncology, supporting earlier detection, more accurate diagnosis, and better treatment planning. When we evaluate the combination of image processing and UNET, we can say that when enhanced images are passed into a UNET model, the network can identify tumor boundaries and subtle pathological structures more effectively. This combined approach increases the segmentation accuracy, reduces noise-related errors, and strengthens early diagnosis and treatment planning. Evidence from multiple studies support this. For example, Ulay and colleagues segmented 3D brain tumors after using a full pre-processing pipeline that include normalization, bias correction, histogram equalization, and artifact removal. Their system achieved a DICE score of 0.91. And Ilhan also applied denoising and histogram-based enhancement on breast dataset and reached DICE score of 0.94, 85, and 88. In ovarian cancer research, Jaya Sundari and Brita developed a UEDL-OVD model, which starts with construct enhancement using a black window optimization algorithm. This produced an excellent contrast values, and full model achieves strong precision and recall. Another good example study, Rudiansh et al. Combined gamma correction and medium filtering with UNET for cervical cancer segmentation, and they reached to 89% accuracy. Overall, these studies show that pairing image enhancement with UNET or similar deep learning models significantly improves diagnostic performance, and enhancement reduces noise and variability, while UNET delivers strong structure segmentation together, enabling more reliable tumor detection and earlier clinical intervention. In this review, I examine how image processing techniques and the UNET architecture work together to strengthen cancer detection and create a background for the rest of the study, of course. Pre-processing steps improve the quality of medical images, creating a strong foundation for analysis. And when these enhanced images are fed into a unit model, the model can more effectively recognize tumor boundaries and other critical pathological structures, resulting in higher segmentation, accuracy, and more reliable clinical interpretation. The other effect of feeding enhanced images to unit algorithm is decreasing the computer processing time, which means decreasing the computational cost. And this synergy not only boosts the performance of the deep learning model, but also reduces diagnostic errors and supports stronger clinical decision making. Looking forward, research should continue to focus on designing optimized pre-processing pipelines for different imaging modalities and exploring next-generation deep learning architecture that can further sharpen segmentation quality. The continued integration of these methods has tremendous potential to advance early diagnosis, improve treatment planning, and ultimately deliver better outcomes for patients across oncology and other data-driven medical fields. That's all that I want to say. And if you have any question, I would love to hear and try to answer.
Thanks for your presentation. Dear participant, do you have any question about the study?
Can I have one?
Okay.
Yeah, sure, I'm listening.
You presented a review, so this review should motivate us using UNet for cancer diagnosis. So what's your next step for this work?
Okay, so my research is focused on using image enhancement techniques to strengthen the performance of unit algorithm. And the main purpose is categorizing histologic subtypes of the ovarian cancer. So when I was working on my literature review, I just found out that there were too many methods that can be combined together, and we can create lots of hybrid approaches and ensemble approaches to increase the performance of different unit models. So the next step of this study, which is waiting in the queue for the publication, is including a pipeline to create ground truth for histopathologic images. And then the other one is, which is waiting in the queue as well for the publication, is covering using image enhancement techniques to increase the segmentation performance of some various unit algorithms. And one of those approaches are newly presented by us.
Thank you and good luck.
Thank you. I think that's all, and thank you for listening.
Dear participant, do you have any question? Okay, no question. Thank you again. I wish you success.
Thank you.
Next paper belongs to dear Cansu Çiğdem Ekin.
Yes, I am here.
Okay, if you are ready, you can start your presentation.
Thank you.
You have 10 minutes, please.
Okay, thank you. Okay, today I will present my paper titled Operational Efficiency and Cost Optimization in Corporate Information Technology Management, and it's a qualitative case study on chaos operating system. And in the presentation, I will give information about what's the meaning of total cost ownership in facility management and what are research objectives. Then inform some studies related with the literature review. Then I will inform about methodology part of our study and how is the kiosk architecture then next. And lastly, I will give information about our findings and conclude with the discussion part. Okay, as an introduction, the key point is that the only 20% of the total cost of ownership originates from the initial acquisition cost, while the remaining 80% includes administrative expenses related with the system management and the operations like that. And this distribution, as seen in the chart given in this slide, illustrates why open source solutions and particularly systems like Kios is a special operating system developed for an enterprise use, and its purpose and how can it can be used for a strategic alternative in a facility manage different facilities, and the total cost of the ownership includes several components. Some of them are related with the hardware and the software expense, and as given here, some of them are related with the administrative cost. And traditional closed source operating systems such as Windows or macOS significantly increase this value, the total cost of ownership. And what are these? As you see here, high licensing cost and the frequent upgrade requirements, specialized expertise demands for system administration, and the complexity of the IT environments sometimes increase this value, and the higher technical expertise requirements elevating the operational cost also can be included in this value, total cost of ownership. And then we look literature review and examine the components and the strategic role of the total cost of ownership. And we saw that there are several studies focusing on this domain. And one of the study coming from the Gartner's group, and in their study, they aimed to reveal hidden costs, and such as management and support beyond the visible costs of purchasing ITSS. And they use two complementary approaches to reduce the total cost of ownership. One is the centralization, the other one is the standardization. And these strategies form the foundational components of the effective IT governance framework. And they see that at the end of this study, tightly managed standardized environments, they compare tightly managed standardized environments and a loosely managed setting. And a particularly finding is that the tightly managed and the standardized environment, a single technician can support 77 end user, while the loosely managed environment, this number is only 80. And this demonstration is direct impact of the standardization and centralization on operational efficiency. And in another study, it's related with the use of the open source software to minimize total cost of ownership. And the case study demonstrated that the switching from commercial to open source solution results in 78% to 83% reduction in total cost ownership over 5 years. The French national government migration of 37,000 desktop computers to Linux-based system, resulting in up to 40% reduction in licensing and the support cost, demonstrates the scale of this transformation. And as we see in this study, to minimize total cost of ownership and to increase the total benefits of the ownership, we can use open source software as an alternative to closed source software to manage effectively our facility. And in this research methodology, we use a qualitative case study to investigate effects of the kiosk operating system on a corporate efficiency and cost optimization. The primary sources for the study include chaos technical documentation and architectural specification and internal IT management tools, and some are related with the automation system description. The analysis evaluated the potential impacts of the three main components of the total cost of ownership, the direct cost and the personal cost. Distribution developed with kernel level enhancements and designed as a fully domestic solution, as written here. It's a Linux distribution developed with a kernel level enhancement and designed as a fully domestic and national solution due to its low resource requirements and cost efficiency. And it offers significant cost advantages over the traditional operating system, as we talked in the previous slides, when we compare with the closed operating system like Windows and macOS. And when we look the chaos enterprise features and the healthcare implementation, now the chaos operating system is used in 6 major city hospitals. Lots of them are şehir hastaneleri, and currently serve by the chaos, the numbers that you see here, 70,000 of users related with this operating system. They use this operating system in management healthcare system, in hospital system. And its secure session, and when we look its critical capabilities, it uses LDAP protocols, and it has an identity verification, access management via e-signature integration, and it's also cloud-based management. It supports this feature also, and it has a customizable user interface, shortcuts, workflows, and also this operating system supports for both traditional and open source Office application. And the healthcare sector is characterized by the necessity of uninterrupted service structure, the need to do safeguard sensitive patient data, the highly complex IT infrastructure consisting of the mixture of the legacy and the modern system that must operate in integration. And when we look the management and automation ecosystem for kiosk operating system, it has a centralized management. All network connected clients monitored and managed through the central console, and it has a secure interaction via LDAP and Active Directory, and it has operational efficiency, enhanced efficiency without human intervention in routine processes, and it provides an IT automation with an execution of the system monitoring, backup, and the security auditing. As a finding of this structure, the features of the kiosk support centralization and standardization strategies, which are the critical to control total cost ownership and increase the total benefits of ownership. And these are, and at the end of the day, we see that these are related with the direct cost and the hardware infrastructure cost and the operational and personal cost. And we minimize these critical components related with the total cost of ownership with the kiosk operating system. And lastly, the total cost of ownership advantages provided by kiosks with this specific operating system based on Linux and are consistent with the cost reduction findings of the given samples in the literature. One is related with the open source software transition and the primary source of the saving arise from the optimization and of the administrative cost, which account for approximately 80% of the total expenditures. Thank you for listening. If you have a question, I can take.
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no questions. Thank you again. I wish you success.
Thank you very much.
Next paper belongs to dear Radka Nacheva.
Hello, can you hear me?
Yes.
Okay,
Are you ready to present?
okay.
You
Okay.
can share your screen.
Yeah, can you see my screen?
Yes. You have 10 minutes, please.
Hello, it's nice to be into the conference again this year. The paper that I will present is related to AI-powered Moodle modules for advanced e-learning, and the one of the problems that we have now is the integration of AI into the educational process and the delivery and engagements of the students by adapting the content. So the AI enhances efficiency by automating tasks, allowing students to concentrate on case studies instead of the content during the classes. There is a need for AI tools to be inclusive, ensuring more accessibility for individuals with different needs. And the current paper has a purpose to explore the possibilities of integrating of AI-powered Moodle modules into the digital education to improve collaboration in learning environments. And we conducted a pilot experiments that show the integration of AI into Moodle can increase efficiency, learning outcomes, and overall satisfaction for learners and educators. And the main research questions that seek to address is how can AI-powered Moodle modules be effectively integrated into learning process to enhance students' experiences and improve instructional efficiency. And some objectives are summarized like exploration of AI-powered Moodle plugins with specific focus to adaptive content generation and evaluation of the benefit, challenges, and the implication of integrating this AI Moodle based higher education environments. Some advanced research we made about the AI, which offered significant advantages in content generation and enhances LMS assessment process. It enables teachers to automate grading, to provide feedback, and utilizing sophisticated natural language processing. AI tools in creating quizzes and summaries could expand learning materials and aligning assessment with objectives. And AI modules enhance collaboration and experimental learning while also increasing teacher productivity through intelligent dashboards. We researched some modules which could extend Moodle functionality and to be integrated into the learning process, like this AIC, which is content generator, and it integrates generative AI into Moodle auto editor, which is enabling educators to create course content such as summaries and activity instructions. Another are these AI tools like generative AI question bank, which is AI text to question generator, assist in automating test creation and transforming course documents into various types of questions to Moodle question bank. Empirical studies indicate that AI-generated questions reviewed by instructors can hold reliability similar to human-centered ones. Turing Key is one of the Moodle modules which extend AI question generation aligned with Bloom's taxonomy, allowing the generation of diverse questions from uploaded lecture materials, explorable as Moodle XML. AI plugins address academic integrity with tools such as detecting AI and copy leaks integration, providing analysis of generated AI content or plagiarized content, which is ensuring trust in the online education, and other content creation tools like Tiny MCE, the built-in AI tool, offers features for summarization and translation, which is adding AI-driven capabilities in Moodle. And this local AI manager plugin manages language models for Moodle, which is supporting user segmentation and integration in various AI tools while providing analytics and role-specific collaboration, which means we can extend the Moodle environment to be more productive during the classes, not, of course, to generate the content like lecture notes and other study materials. We conduct some experiment which is studying the integration of AI into the Moodle platform, and we follow this procedure like environment setup, Moodle plugin setup, and Moodle courses setup. That is the initial stage. The next stage, AI content generation, is related to utilization of AI modules to generate lecture notes and assessment tests, supporting teachers in creating learning resources. And AI content evaluation is the next third stage in our research process, where the assessment of quality of generated content through AI-based grammar checks and readability analysis to ensure it meets academic standards. And final phase is reporting content issue, which is summarizing assessment result in providing feedback for refining AI outputs and improve on the prompts for better future integration. That is a kind of systematic process from course setup to evaluation, which is focused to balance technical implementation and pedagogical quality. So we conducted some experiment with AI-generated content. We set up environment in a cloud version of Moodle via MoodEI, which is using Moodle version 4.5.5 And with the build from June 2025, we made a connection with OpenAI ChatGPT, which is activated to the site administration, and we enabled the course assistance and text editor in Moodle. The Moodle modules utilized here in this experiment is Tiny MCE, which is visual here on this slide. It is integrating AI module for direct connection with the ChatGPT, and a test course title Web Technology was created, divided into 4 sections: lectures, workshops, assessment, and references. And AI content generation phase is testing the content which was added and focus on the extension of the lectures and question banks for assessment. Some topics are created, like introduction to HTML, basic HTML tags, and the introduction to the CSS. And here on this slide, we can see 3 of the, some of the question banks which are generated with the AI content. They are generated based on the lecture notes which are added into the mentioned sections. Here we can see that sorry, so something I want to see the table. So here we can see a table which is containing 14 metrics used to assess AI generated content, with first 6 metrics calculated by WebFX, and others are generated by Grammarly. One of the here we can see the AI content, which is supportingly generated with these AI tools, and AI question bank. 3 test lectures, materials, and question banks. 3 question banks are generated with these modules, and we assessed the quality of the content according to the metrics in the first column. For the lecture 1 materials, is identified that they are more complex according to this Flash Kinsight Reading Easy score, which is 52.3, and the grade level score of 10, while the question bank 1, which is associated with this lecture, is simpler with readability score of 87, and the lecture 1 contains 58% of unique words, which means it has a richer vocabulary, which is compared with the question banks. And the metrics from 3 to 6 in the table suggest that lecture 1 is relatively difficult to read, intended to upper secondary or university students. I mentioned that the course which is used as a basis for the experiment, that is web technology. It is specifically in the computer science, which means is more technical content provided. And it is normal to for the lecture notes and for the questions to be more difficult than the high school materials, for example, which is the basis for this metrics Flash Kinsight, Flash Kinsight Reading Easy and grade level, Gunning-Fock scored so more. And lecture 2 is slightly easier than lecture 1 materials, and according to the Grammarly metric score, its points are 97 out of 100, which is good for the readability. Question bank 2 shows improved lexical variety comparing with the question bank 1, and lecture 3 receives scores from 93 and 96 from Grammarly. The question bank 3 is the easiest with average of 4.6 words per sentences, while lecture 3 materials has 31% of unique words, and the length of the sentence is about 10 words. And here, as a conclusion, we can say that integrating of AI modules enhances content delivery by generating some extended materials and self-study materials, but the role of instructors is crucial for maintaining pedagogical quality, and AI content is generally readable and lexically rich, but however, it may lack of depth and clarity. The instructor expertise for the context is cannot be replaced. The analysis indicates a variability in AI-generated complexity, enhancing the need for educators to provide structured examples. And AI can facilitate learning in fields like programming by creating code snippets, improving engagements while prioritizing content relevance to group students into smaller teams and somehow to automate some repeatable tasks. But these modules cannot be used to generate the main content where the student could use for their preparation. And thank you for your attention. That was the last slide, and I'm open for, of course, for questions.
Okay, thanks for your presentation. Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you success.
Thank you.
Next paper belong to dear Deniz Karhan.
Hello everyone, I'm
Hello.
share with you my
If you are
presentation.
ready, you can start your presentation.
Yeah, can you see that?
Yes.
Okay.
You have 10 minutes, please.
Greetings to everyone. Today I will present our study on 6G and quantum AI-based protocols, focusing on security, computing, and data processing scenarios. Corresponding authors Merve Gülle and Sedat Çimen have contributed significantly to this comprehensive analysis. We begin with a historical overview of mobile network evolution from 1G to 6G, establishing the technological trajectory that brings us to today's research frontier. Following this, we examine the architectural components of 6G wireless communication systems and introduce the fundamental principles of quantum computing. The core of review focuses on quantum AI-based protocols, their data processing scenarios, and security architectures. The evolution of mobile networks has seen major advances in speed and capability over the past 4 decades. While 1G provided low-quality analog voice only, 2G introduced digital communication with SMS, with 3G mobile internet-enabled video calls and smartphone apps, and 5G LTE supported high-speed HD video streaming, and 5G now delivers up to 10 gigabytes per second with ultra-low latency for autonomous vehicles, smart cities, and IoT devices. And expected in the 2030s, 6G aims for speeds up to 100 gigabytes per second and deep AI integration. Literature indicates that 6G networks will utilize four distinct segments working in coordination to provide ubiquitous coverage. The space segment employs low Earth orbit satellite constellations for global reach, while the air segment leverages high altitude platform stations and UAE for dynamic coverage adaptation. The terrestrial land segment incorporates terahertz frequency bands and ultra-dense cell deployments to achieve unprecedented capacity in urban environments. Additionally, the C segment uses intelligent buoy networks to extend connectivity across oceanic regions. I'm sorry. Understanding quantum computing requires recognizing its fundamental differences from classical computation paradigms. While classical computers operate using bits that exist in definite states of 0 or 1 with deterministic outputs, on the other hand, quantum computers employ qubits that exploit superposition and entanglement to produce probabilistic results. The processing capabilities differ dramatically as classical deterministic gates enable only sequential or limited multi-core parallelism, whereas quantum gates such as Hadamard, Toffoli, C-node operators unlock exponential parallelism. Physical implementations also differ significantly. While silicon transistor technology dominates classical systems and quantum computers use superconducting circuits, trapped ion systems, and photonic platforms. Current quantum computer architectures exhibit diverse physical implementations and system-level designs, each with distinct advantages and limitations. At the physical level, superconducting qubits utilizing Josephson junctions offer very high gate speeds, but suffer from relatively short coherence times around 100 microseconds and error rates between 10 to the minus 3 and 10 to the minus 4. At the system level, monolithic architectures place all qubits on a single platform, providing low latency and high fidelity, but scalability remains limited. And on the other hand, distributed architectures connect multiple quantum nodes through quantum communication channels, offering better scalability through modular structures. The fundamental architecture relies on three critical components that enable quantum-enhanced learning. First, quantum circuit architectures employ parameterized quantum circuits with trainable parameters, variational quantum circuits for hybrid optimization, and quantum gateways that perform multi-qubit operations. Second, data encoding strategies determine how classical information maps onto quantum states. These strategies include state encoding, amplitude encoding, and observable encoding using Hamiltonian operators to map data properties. Finally, third, hardware platform limitations in the current noisy intermediate scale quantum era present significant challenges, including decoherence effects, noise problems, and limited qubit counts. The data processing pipeline in quantum AI systems follows a sophisticated workflow from encoding through training to inference. Classical data undergoes quantum encoding, where information is mapped onto Hilbert space with different data classes represented in distinct regions sorry, of this high-dimensional quantum state space. And encoded quantum states are then processed through fundamental paradigms that leverage quantum properties for advanced learning. However, the training process faces significant challenge that current research aims to address. The integration of quantum technologies into 6G security frameworks represents a comprehensive approach spanning multiple network layers. Research literature proposes a layered architecture that combines post-quantum cryptography algorithms, quantum key distribution protocols, and specialized quantum networking devices to ensure end-to-end quantum-safe communication. This architecture manages the complete security lifecycle, including secure key exchange, key lifecycle management, and authentication across core, edge, and transport network layers. And quantum AI strengthens these security mechanisms by supporting advanced authentication protocols and quantum enhanced system update procedures. Despite the promising potential of quantum AI integration in 6G networks, several critical challenges must be addressed before practical deployment. The current noisy intermediate-scale quantum hardware limitations and immature quantum error correction mechanisms pose fundamental technical obstacles to real-world implementations. Scalability concerns are particularly pressing as current quantum processors with limited qubit counts and high error rates must eventually support 6G ecosystems connecting millions of devices simultaneously. The integration of quantum AI into 6G networks represents a transformative milestone in communication evolution, promising substantial improvements in both security and computational capabilities. The literature consistently highlights how quantum AI-based security architectures can improve computational performance while also enhancing network protection, and future progress will largely depend on increasing research efficiency in quantum systems and establishing comprehensive international standards. Our literature review consists of publications from many disciplines, and I will share that you. Thank you for your attention. If you have any question,
Thanks
please.
for your presentation. Dear participant, do you have any question about study? Okay, no questions. Thank you again. I wish you
Thank
success.
you.
Dear Betül Karaoğlan, are you present?
Yes.
You can share your screen. You have 10 minutes, please.
Okay. Hi, everyone. I'm Betül Karaoğlan, and today I'm going to present our study titled The Potential of AI-Powered Digital Twins in GSM Base Stations. First, I'm going to briefly explain our purpose and introduction of the study, then the digital concepts and AI applications in communication systems. After that, I'm going to briefly explain AI in GSM sector in potential and advantages, then combine two technology, digital twin concept in GSM base station and benefits of AI-powered digital twins. Then I'm going to finish my presentation. In recent years, the telecommunication sector, like many other sectors, has undergone a significant transformation due to rapid growth of AI solutions. Along with technologies such as big data, machine learning, and deep learning, AI stands out with its ability to extract meaningful information from complex data sets. In this context, AI-based solutions provide significant advantages in the communication area, such as optimizing network management, increasing service flexibility, and reducing costs. Global system for mobile communication, GSM base stations play a critical role as one of the fundamental building blocks of mobile networks. However, the complex nature of these systems makes management, maintenance, and updates difficult, leading to costly, time-consuming, and often inefficient processes. Normally, the management and maintenance processes of GSM base stations have been carried out through manpower-based operations. This study was prepared to present the current status of the object by bringing together the findings in the existing literature and guide to future research. The purpose of this study is to explain the potential of AI-enabled digital twins in GSM base stations and assess the potential contributions of these technologies to telecommunication field. The digital twin concepts initially described by Dr. Michael Greaves in 2002 as a virtual representation of a product or process that incorporates physical, functional, and behavioral qualities. The concept began with the creation of a virtual representation of a genuine factory or manufacturing line to improve and streamline industrial operations. DT is a system that goes beyond typical computer-based simulation and analyzing by replicating all of the elements, processes, dynamics, and hardware aspects of a physical system into a digital version. The two systems, both physical and the digital one, coexist side by side, sharing all inputs and processes using the real-time data communication and information transfer. By incorporating various systems such as the Internet of Things, AI, 3D models, next generation mobile communication, VR and AR, distributed computing, transfer learning, and electronic sensors, the digital counterpart of the real-world system can provide effective monitoring, analysis, evaluation, and predictions. The widespread adoption of DT technology across many industries also shows there are alternative ways to create, manage, and operate complex systems. It is predicted that applying this technology in communication system will lead to more efficient network management and early detection of potential issues. Considering the expected network density and complexity, especially with 5G and beyond, the importance of the DT becomes even greater. Base station DT can monitor network load in real time, assess performance, and identify possible congestion ahead of time. The DT enabled real-time performance analysis by virtually modeling network components. Continuously monitoring is another key benefit of the DT in base stations. Ongoing surveillance of physical systems allows for early detection of potential failures and helps reduce operational problems. In a network, DT can oversee the traffic and forecast overloads before they happen. These applications are crucial for optimizing network resource use and enhancing user experience. When the literature examined the most frequently used AI models and algorithms in DT applications for communication systems, their main usage areas and typical applications are given in the table. As an area of usage change, the preferred algorithm and model is going to change. And this architecture integrates the digital twin technologies with collaborative edge cloud system to maximize the potential of next generation 6G networks. The system processes data collected from the physical world via distributed infrastructure to enable optimal resource management and autonomous decision making. GSM base stations, which frequently have intricate configurations and cover wide areas, are crucial parts of the mobile network. As I said before, high data traffic, shifting network condition, and rising user demands make managing this station difficult. One promising solution to these problems is the integration of AI into GSM stations. Among the many advantages of AI, its sophisticated data analyzing skills, which can process large data sets and produce insightful information about the network performance. In order to increase the network stability and dependability, it can also predict possible issues and encourage preventative actions by analyzing and optimizing energy use through sophisticated and intelligent algorithms. AI technologies can increase the energy efficiency of GSM base stations. To manage GSM increasing complexity and enhance their operation, the DT concept is gaining popularity. A digital twin is essentially a virtual replica or any simulation, and it has some fundamental principles like virtual mirroring, real-time synchronization, model and tracking, and its key features are real-time monitoring, predictive analyzing, and proactive management, and also improved efficiency. Maintenance and management of GSM base stations are vital for operators, and adopting a predictive approach is essential to minimize network disruptions. In this context, using highly advanced digital twins offers significant advantages for implementing predictive maintenance, such as real-time data analyzing, pre-failure response, optimized maintenance planning, and continuous learning and improvement. As a conclusion, in this study, we examined the use of AI technologies and concepts of digital twins in GSM base stations. Managing and maintaining GSM base station is crucial for operators, as the effectiveness of these processes directly impacts network reliability and performance. Integrating AI technologies and digital twins offers substantial benefits to operators. Incorporating technologies like AI and big data analytics will boost the predictive capabilities and automation of digital twins. Ongoing research on the application of digital twins in base station is vital for shaping future communication technologies, fostering innovation in both academic and industrial area. These are our references, and if you have any questions, I will try to explain. Since it's 10 minutes, I boosted my presentation. Sorry about that.
Okay, thank you. Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you success.